Hi everyone, hope you're having a good day. I'm Shashank, a PhD student in Middleware Systems Research Group at University of Toronto. I'm here to present FabUnit. So, with the rising popularity of blockchain, this technology had spurred the corporations and government agencies to revisit their business processes. They came up with novel solutions for their existing problems leveraging blockchains. However, privacy and security still remain the key requirements for their software systems. As a result, most of their solutions are based on private blockchains. Hyperledger Fabric is a widely used private blockchain system with many plug and play functionalities. Though the budding interest in blockchains is exploding, the developer ecosystem for building such systems is not matured yet. So, what is the problem? There's no mature testing framework for the blockchain systems. The developers are using standard unit testing techniques for testing the workflows in the permissioned blockchain. However, unit testing blockchains, especially the permissioned ones, is quite different. They can be expensive if the traditional methods are used. For instance, setting up the environment for new tests might involve setting up of the entire network or resetting the data. We were not able to find a testing framework for Hyperledger Fabric client which reuses the setup execution for unit testing the end-to-end transaction workflow. Such tools are required for quick and reliable development of private blockchains in enterprises. Let's have a look at this particular code snippet of a unit testing class. The two methods here have annotations before class and before. The before class method registers the users and sets up the client. This method is run once when the unit testing class is initialized. And the before method cleans up the data by deleting existing records and reinitializes the ledger. We run this method before each unit test method is run. Let's look at this both unit testing methods, the query all and query by ID. Both are just querying the data and there's no state change. However, we are running the before method twice. We are spending time executing before method to clean up the data even when there is no state change. This is clearly a problem which we wanted to address. We wanted to reduce execution time by reusing the setup to run all the methods that do not change the state. We present FabUnit, a framework for faster execution of unit tests in Hyperledger Fabric. The approach we took is divided into two phases, the parsing phase and the execution phase. Before we dive in, let me first define the safe and the unsafe methods. Safe methods are the functions which do not alter the state of the blockchain. Read operations are examples of safe methods. Unsafe methods are the functions which alter the state of blockchain. Create, update, and delete fall under this category. Here, red color is used to mark unsafe and green color is used to mark safe methods. Let's look at the step 1. The parsing phase starts with the chain code parsing. We identify safe and unsafe methods in the Go chain code and then use that knowledge to parse Java invocation classes to mark safe and unsafe, and finally the testing class. We segregate safe and unsafe methods as shown in the figure 2, like step 2. The second phase is the execution phase. In this phase, we tweak the original execution flow to reuse the setup. We extended the Java block JUnit4 runner class to create our own Fabric unit runner class. Have a look at this step 3. The execution first runs the before method and then runs all the safe methods and the first unsafe method. And finally in the step 4, we run the sequence of the loop of before and unsafe methods. This reuse of setup is expected to provide huge improvement in time, which we'll see in the results. During our research, we found very little work done on unit testing of Fabric. The official documentation did mention about unit testing Go chain code, but not about the entire workflow. However, we found some related work in the Ethereum space. Truffle is a development environment which offers unit testing on Ethereum. It lets you use the same smart contract to test all the unit tests written in the same file, but it had some restrictions. SolUnit solved that issue by overriding JUnit framework and also motivated this work. We found that SolUnit cannot be extended directly to Hyperledger. Unlike Ethereum, where each deployed smart contract had a unique address and you could deploy a new smart contract to reset the setup, in Fabric, even if the chain code, which is uniquely identified by ID and version number, is updated by tweaking those parameters, the data stored on each node is not erased and it can be accessed. So we had to design a customized framework to meet the requirements of Hyperledger Fabric. Let us look at the experimental setup and the results. We have taken the examples published in the Fabric documentation and wrote our own test cases because there are no test cases published officially. The experiments are done on Hyperledger Fabric 1.4 with Java 1.8 client and Go chain code. We set up the network with an orderer and two organizations, each having two peers and a certificate authority. Consensus requires at least one signature from each organization. We measured the execution time in milliseconds. All the unit test classes we wrote had equal number of safe and unsafe methods. The execution time might vary depending on the number of test cases, number of safe and unsafe methods, and their complexities. Clearly, we could see a great improvement in the testing capacity of about 29 to 46% depending on those factors. To conclude, we presented FabUnit, the first unit testing framework for Hyperledger Fabric to reuse the execution setup and hence faster execution of unit tests. To achieve this, we parsed the chain codes and the client-side codes to identify safe and unsafe methods. We provided an easy interface by extending JUnitRunner class. This can be easily integrated to any of your new or existing projects. We have seen great results, and this is just the beginning in the direction of unit testing blockchains. Thank you and stay safe.